Welcome to Data Center Dialogues, the podcast that empowers your data center knowledge. I'm Francesca Van Thielen, and today we're exploring one of the biggest shifts in IT strategy, the rise of AI and its impact on infrastructure. Artificial intelligence has become a strategic force, driving the need for faster computing, cleaner energy, and smarter ways to manage data center infrastructure. To explore this transformation, I'm joined by two experts who live right at the intersection of innovation and infrastructure. Michael Verveckken is Managing Director of Fujitsu Belgium, leading the company's cloud-first and digital transformation strategy. He brings over 15 years of ICT leadership experience, focusing on innovation, sustainability, and partnerships with Belgian startups and scale-ups. Joining us as well is Martin Canter, head of the Smart Region Hub at FARI, AI for the Common Good Institute here in Brussels, where he drives research on digital twins, smart cities, and responsible AI. He translates complex European AI initiatives into real-world applications, bridging the gap between the academia, public and private sectors, and civil society. Gentlemen, a very warm welcome. Michael, I'd like to start with you. Fujitsu has been shaping AI projects across multiple sectors, and a very interesting one is within the medical and genomics field, areas where, precision and ethics and data handling is absolutely critical. So can you tell us a bit more about one of these projects and how did AI transform the outcome within that specific project?
Yeah, sure. Thank you, and happy to do so. As you mentioned, Fujitsu is active in a lot of projects, but I think especially within the medical field, where we can actually really see the impact on people's life, I think is one of my favorites. So an example of that is we're working together with the Barcelona Supercomputer Center to really take the data from genomics and the patient data in order to make sure we can have more personalized and proactive medicine and essentially in order to improve people's lives. That's one of my favorite projects. Yeah.
And where does AI come in here?
Well, so in medicine, there's a lot of data which is available. So both on the regional level, on country level, but on European level, there's more and more initiatives in order to share data. So common data spaces. But at the end of the day, we need AI in order to help and to interpret a lot of that data to make sure we make correlations. And this is not only, I would say, plain text data, but for example, also X-rays and scans. And really in order to make sure that we use technology in order to identify the patterns, use it, and also like in the case of the project in Barcelona, also use genomics in order to make sure that we can use the right and give the right medicine to the right people, but also make sure that we can actually identify certain patterns in order to see, is there a risk of a certain person to get a certain disease?
Mm-hmm. Well, healthcare data is very, it's sensitive and it's complex. So what kind of infrastructure do you need to make AI work responsibly in this domain? Well,
I think it's obviously a very broad question, the infrastructure. But I would have to say, in a lot of cases, it needs to be local infrastructure, because just putting a lot of this data in the cloud is not necessarily the right idea. So you need a lot of computing power, the right data centers, the right cooling, the right storage, but also make sure that it's secure, because at the end of the day, we're talking about patient data, and which is obviously very sensitive. You don't want it to be leaked and be available.
And what are the main or the core principles if you say we want to secure that data, that's sensitive, important data?
Well, the main principles are that essentially you want to, as much as possible, reverse the way you act and say, we don't trust it unless. So really have a zero trust principle. At the same time, try to anonymize as much as possible. Because, for example, a research project doesn't need to know the person's name in order to make sure that they draw conclusions. So really make sure that and in a lot of cases, we already apply a lot of those things, because at the end of the day, even we're talking Barcelona, but even today, I think most Belgian citizens have some sort of health data available online or through the hospital, etc. So in a lot of cases, it's really using a lot of common sense, also driven by regulations from the European institutions, of course, to make sure that our data is protected.
Okay, thank you, Michael. Martin, you're working in a very different but very ambitious field. You are helping cities and municipalities build digital twins. Maybe start with just explaining what a digital twin is.
I'll give it a go. A digital twin is an interesting concept that's a little bit vague depending on who you ask it to. But the idea is that you have a physical situation on which you gather data. So usually here applied to the cities, but it can also be on the human body. And when collecting that data, you basically can represent then the physical situation in a digital or numerical way, right? And that's basically the first step. The second step is then to run models or simulations to be able to gain insight on what's happening. And the last step is then to use that as a decision-making process, whether it's autonomous or real-time or not. It depends a little bit on the level of autonomy that you want to give to your digital twin. But that's kind of the loop that you want. Yeah. And in the end,
it's temporary.
No, it can be continuous. You can have a complete digital twin running all the time. For example, best example would be just the weather system. You have digital twin of the atmosphere going on all the time to be able to forecast the weather tomorrow. And so as time goes forth, new data is coming in, so you update your situation, and then you can make new forecasts on what's going to happen tomorrow, and then the behavior of people changes, whether they need to take an umbrella to get out. Well, we do basically the same stuff, but for cities, and the best example would be the impact of traffic, for example, on how many cars are coming inside the city, and how many roads are closed, so that you can say, okay, well, is it going to be problematic? Should we take action on that or not? Mm-hmm. So that's kind of the idea.
So where does AI come in here?
AI comes in mainly because, well, it's based on data collection. So part of it is being prepared there to be able to process the data, and then the actual simulation themselves. That can be simple models on, okay, well, you don't really need a lot of, you don't need AI to be able to make a weather forecast, but you need AI for a traffic situation to analyze how it's going to go, or for any type of other simulation in your city with, let's say, water permissibility of the ground or something like that. You have more complex model that you can use to make those forecasts and understand what's happening inside the city.
Mm-hmm. And what kind of infrastructure supports these simulations?
A lot. The first bit would be all the sensor that you need inside the city to be able to collect the data to begin with. So we usually forget that data collection starts with putting sensor inside the city. They can be cameras, they can be sensor that people use on their phone, for example, or put themselves on the roofs or on the windows. Then once you start collecting the data, you need to store it somewhere. So usually, data center or somewhere in the cloud or private infrastructure, depend a little bit on what you actually need. And then after that, to be able to process the data to train your model, you'll also need specific compute infrastructure. So for the moment, we are following up a lot of EU initiatives that are called AI factories and gigafactories, where the aim is to put those supercomputers at disposal of companies or municipalities that would actually need them, because buying one and running one is very expensive. The more you can share them together, then the better, the more efficient it is. And the training part usually is really just when you build your model that you need it, but you don't need it a lot when it's actually running or to make predictions.
Yeah. If I'm correct, you are using common European data spaces. So what is this, and how important is this European layer?
Quite a bit, for a simple reason that those initiatives, we apply them at FARI in the Brussels capital region, but I'm sure you can understand that the same concept and the same problems are occurring also in Namur, in Antwerp, but also in Amsterdam, in Paris, in any city basically in Europe. So everybody tries to do the same. The best scenario is to learn from each other's experience and experiments, and to see what actually works well as then having an interoperability in terms of data, but also in terms of solutions, so that if you have a solution that's developed and deployed for one city, it can also be copy-pasted, always with some type of adaptation to other cities in Europe. And so the concept of European data spaces is that it comes with a set of governance and set of rules on how to operate such a data space, so that you can basically share data with other stakeholders in a city.
Mm-hmm. Well, it's clear that you both are working with very large data sets for the human genomics and the city grids, just to name a few. So, what does that mean technically? What are, according to you, the biggest technical bottlenecks, for example? Michael.
Yeah. But maybe before again, if I just allow a quick reaction, because I think you started out by saying you're working in a very different field, and I think, as Martin already mentioned, in a sense, yes and no, because if you look at the genomics project, you could also consider it to be a digital twin of a human body, right?
Okay,
So I mean, in the same way as Martin was saying, we can simulate what will happen in a city. You can also simulate on what's happening in a human body. So I think in that sense, on the surface, there might be more similarities than we first see. But I think back to the question, what are the biggest bottlenecks? I think since we have these vast amount of data, and not necessarily the capabilities and the capacities yet to analyze them, I think there's several bottlenecks, and most of them are technical. Some of them are maybe the skills and the people we need in order to analyze and interpret and to build those systems. But at the same time, we don't necessarily have the right data centers or the right compute power or the right storage equipment in order to store all the data in the right places. So those would be for me a few bottlenecks. And maybe a last one, which is more horizontal, would be more the cooling and I would say the energy needed in order to power all those systems. I think we already have issues powering or I would say charging all the cars we have, let alone charging a data center and powering the data centers.
Well, thank you. What about you, Martin?
For us, from experience, the bottlenecks are a bit more focused usually on interoperability of the existing infrastructure or solutions that exist out there that we need to understand how to adapt them then to the to a larger framework, and then to get all the stakeholders to work together. The problem being that, especially in the city, you actually collect a lot of data or get access to a lot of data from different administrations that all have their own IT infrastructure, IT units, and so on. So to get all those people aligned and share the data so that then we can do something with that takes quite a bit of effort and time. Second aspect is, working at university, the research part, let's say, it's easy. It's just research, so you need a bit of funding, a bit of brain power, then you get to it. But transforming that research into then something that can be used, and that's actually going to be used by the public administrations or by the companies, is actually the challenge. So going from a proof of concept to something that's being operationalized and that's running, that's really the difficult part to get it done, because it means that you need to be able to convince either the companies or the public administrations to change the way they work and to start using the tool that has been developed for them.
Michael, you earlier mentioned that the data centers that we know now, that changes are needed. So what kind of new evolution do we need within the data center market?
Well, I think it's on multiple levels. So if you look today, globally, then data centers, they're about 2-3% of the total energy consumption. Tomorrow, the expectations are that will evolve to 10% of the global, and about 50% of that capacity is taken by AI. Now, I think we're all trying to be more sustainable, but if we're gonna, it's a bit of a paradox in the sense that obviously AI can help us to be more sustainable, getting the insights. At the same time, if we're going to increase the energy consumption globally with close to 10%, then that's also, so for me, a long answer to say, I think we need, and that's not only the data centers, but among others, data centers which are more sustainable. I mean, some companies are building nuclear power plants in order to get to the energy consumption. And again, I don't want to open the debate whether that's, but I think today that's one of the best solutions we have. I think Google, Microsoft, AWS, a lot of the big hyperscalers, they're also investing a lot in getting their data centers carbon neutral. So I think on multiple fronts, we need changes.
Yeah, or we have more energy, or we make those data centers using less energy. Is there any innovation emerging in that sense? You see, Martin?
Yes, well, hoping so, yeah. No, the idea for us is mainly to make sure that when you develop a solution, it can be deployed in multiple places so that you don't always redo the same stuff everywhere. Second stuff is also to look at the impact of the solution that you're building compared to the actual benefit of it or the cost of developing it. So it's always a balance that needs to be considered between, okay, if I need this amount of data, those many sensors, this compute power to provide a solution that in the end doesn't really provide a lot of benefits, and I'm not only speaking about economical benefits but also sustainability benefits, and if you see that the balance at the end is zero or negative, then okay, well, should it even be considered to do or not? Is it a better solution than before? And so now we are evolving towards not only looking at the return on investment in terms of financing power, but also in terms of other type of impacts of your solution.
Well, you work with smart cities, and some of those applications, when you build them and when you think about them, is sustainability something that at the start you consider, and that it should be using not too much energy, or is that something that comes at the end?
At the beginning and at the end.
Okay.
No, we are definitely considering that at the end to make sure that, okay, what we build does make sense, and to learn from those mistakes and to see, okay, well, where did it go wrong if ever it went wrong? Still a learning process, but also at the beginning to make sure that the project that we go for do make sense and actually have an impact. And sometimes we're even considering projects that don't always have financial benefit directly, because, for example, looking at the value of a tree inside the city is very difficult. It doesn't really have any direct economical value. But if you look at the life impact of the real life impact of a tree in terms of air pollution, noise pollution, or even heat islands in the city, so the amount of heat that can come during summertime, we see that, well, if you go inside the forest or if you've got a park next to your city zone, it reduces the heat in the city for a couple of degrees. And so looking at this also, well, it's quite important to make sure that the right tools are being developed to take those considerations, those into considerations. And those problems are usually more difficult to tackle without this type of modeling than with.
Yeah. Is that something that happens within the company as well, that you make a trade-off between what's the application that we really want to make and what we want to do and the outcome that we're looking for, and the energy that it's consuming?
Well, I think unfortunately we always need to make trade-offs, but I think what we always try to do is make something sustainable by design. I mean, at the end of the day, the mission of Fujitsu is to make the world more sustainable through innovation. So by 2030, everything we do, we want to link back to the United Nations Sustainable Development Goals, which often gets equated to carbon, but obviously sustainability is much broader than carbon. I mean, clean water. I mean, for example, AI, a lot of earth minerals, so rare earth minerals need to be used in the production. So it's always a trade-off between making innovation for the better. But I think the notion, not only with Fujitsu, but also with other companies, and that's a big shift in the way we do business and the mindset, is that at least we think about innovation from the get-go and make it sustainable by design.
Mm-hmm. I think we should also talk about geopolitics. And well, Europe really wants to lead in trustworthy artificial intelligence, but most of the cloud platforms are still dominated by non-EU players. That's a discussion that we had in the previous podcast. Can we realistically stay competitive with, for example, the hyperscalers in the US? Martin, do you have an opinion about this?
I think that's what we're trying to compete with is a little bit different. If you just want to compete in terms of investment money and so on, it's going to be hard, and I would say that Europe is not as unified. However, if we're trying to compete in terms of impact on life and for citizens as well as trust into the system, there is a definite added value that European Union can bring to the table. And to that extent, I would advise to go and really look it up, all the building blocks that have been put in place by the European Commission, to be able to support innovation in that direction. And so I'm speaking about European digital innovation hubs that are local hubs where companies can go and get support to start looking into AI and will get a bit of funding for that, but also data spaces and get some help to start developing them and implementing them. It's also related to the TEF, so test and experimentation facilities that are common infrastructure inside inside Europe, where anybody that has a solution and that would like to either get some data or get some support to put some sensor somewhere, or to get access to an infrastructure to be able to test something, or to just get the support on how should I be testing a solution, what type of testing should be done on that one, can also get support for that. And so all those building blocks, one next to each other, aim at building a trustworthy and sustainable ecosystem in which, depending on what you need, whether you're a small player or a bigger one, you can actually do something. So the idea is really to support mainly SMEs and in Europe to move forward with that.
Mm-hmm. What's your opinion about this? Can we have like a competitive AI system here within Europe?
So maybe a bit less popular opinion. I don't think we'll be able to compete with the hyperscalers. I think that ship has sailed. Using solutions which don't involve any components from Asia, any software from the US. I think, will there be niche things which we can do? Yes. But at the end of the day, the top 3 hyperscalers worldwide are US based. We've got Alibaba of AliCloud in China. This was a strategy which started more than 10 years ago. Catching up, I don't think is realistic. Will we be able to have maybe solutions left and right? Might we have, is there a case for sovereign cloud? Yes, but will the sovereign cloud not use any US software? I don't think that's going to be the case.
Because, we discussed it in the previous podcast, but like the sovereignty is a big issue. And now we are depending on, American companies, and with the Cloud Act, our data is not absolutely safe, or completely safe. So that is a worry that in both your companies that you probably consider. Do you see any solutions here?
So I think there might be use cases, and especially in public sector and like in defense. Yes, there will be solutions which we can have locally. Are these solutions all economically viable for commercial companies? I think that's going to be a tough one. So yes, if there's enough money involved and if it's strategic, we'll be able to do it. But again, there's a difference between, can we secure the data and not using any components which are not made in Europe? That's a bit, I think, the nuance. So yes, there's a case where we can secure the data locally if you don't connect it to the internet. I think but at the end of the day, like I mentioned, the rare earth minerals. China currently is the only one that can extract them. So even if we could find the minerals, we don't have the technology to extract them. So in that case, I don't think, and I don't think necessarily that should be the case. Again, I don't want to open a political debate. I think a few years ago, this would not have been a non-issue. I think in the current geopolitical climate, I think it is an issue, and hopefully soon we'll all come to our senses and see that it's better to work together instead.
That sounds a bit like wishful thinking, Michael. What about you, Martin?
I would say that to me, being completely sovereign doesn't really make sense either, because, it's very difficult to do. Again, we're not really sovereign in terms of energy either, especially in terms of fossil fuel, for example, import and so on. So likewise for the rare earth metals that are used in this, by those technologies, it's difficult to become sovereign. But do you actually want to be sovereign in those fields? Something else. Usually what we do is we actually just look at the end solution, and can you actually trust it, and do you trust each component that's actually being used to build a solution, and does it make sense? That's basically what you want at the end, whether it was assembled or built or based on some technology from somewhere else. As long as you can trust the end system, that's to me basically already a good enough win. I like to joke sometimes when you're speaking with people from the US, when they say, okay, we want the best solution or the newest solution, they go to the US. Sometimes when they want something that's actually trustworthy, in which they say, okay, we're not only looking at how much money we can make out of that, but rather whether it has been built solidly, then European solutions are usually quite good also. And then finally, in terms of sovereignty, most people forget that all those chips are usually based on ASML company making those chips to begin with, or those lasers to
That's
do
a Dutch
them.
company.
Yes, and it's even further than that. That company is also based on a German mirror maker that's also being used to actually make those lasers. So there is always going to be interdependency on technology that's coming from left and right. So I'm not really too worried about that. I think that the most important is going back to the, for example, healthcare sector. As long as you know that your data can be safe somewhere on whichever machine it has been built and you can trust in the process, that's good enough for me to be able to.
That's interesting. It's a different sound that we're hearing now. Thank you. Well, both of you collaborate with Horizon Europe programs. So who wants to elaborate on or explain what this is? And Martin.
Trick question. I'm not sure I can present it completely, but basically it's a program from the European Commission, which I'm sure, that's aiming at, usually for a couple of years, setting up a couple of programs on what they would like to see funded. And then they usually open those calls for any partnership of, consortium of companies, municipalities, research centers, academia, and so on, to group up together to challenge specific topics. And so usually you only get a topic or a couple of ideas on that, and then you need to bring up your own solution for that, or what you would like to do, and that's how you get funding. That's to be honest, at FARI, a lot of our funding actually comes from there. So last month was a bit long, or actually 2 months ago in September, because we had a lot of deadlines of proposals to submit. So it was a lot of writing and meetings to be able to agree with everybody on what you want to do.
How is the program of Horizon Europe helping Fujitsu in being more innovative?
Yeah, so part of Fujitsu is also doing research. So that's where we do research together with the European Union, European Commission. And it's in multiple domains. So some of it is around quantum computing, some of it is around ethics and AI, because there's also a lot of ethical questions. If you have an AI making decisions, so for example, a car driving by itself, and it's going to crash, and there's two people standing there, and it needs to hit one an old, one young. Which one do you go for? In some cultures, you would go for the young one. In Japan, for example, because age is considered to be a virtue, and in Europe, we probably would go maybe towards the young one still has a lot to live for. So I mean, those kind of questions. How do you answer that? What kind of algorithms do you use, etc. But also around blockchain, how do you make sure you make data immutable? Those kind of research projects in order to contribute to the overall goals of Europe.
Yeah. I have a last question for both of you, and we ask it to all our guests here in this series of podcasts. Is there one belief or consideration regarding data centers that you think we should question more often? Martin is looking at you, Michael, you're the first one.
I'll go first. It's so might sound strange, but I would say bigger is better. I think we should question that. So it's not because you have more compute power that necessarily you will get a better outcome. And I think as technology is evolving, we should question everything. Maybe there's something which might be more modular, closer to the customer, closer to the citizen, which might make more sense. Being distributed, looking at the different architectures as we move forward. But I think it's not necessarily because you have a bigger data center, a bigger compute power, that the outcome will necessarily be better. I think you consume more energy, but I don't think the outcome will necessarily be better.
Okay, well, thank you. What about you, Martin?
I would say that's something that we're actually challenging actively now with companies. It's the concept of data sharing. It's very difficult to go to a private company and tell them, okay, well, we'd like to use your data. Usually for research, they're still open to do that. But if it's for different type of usage, they're always like, okay, what can I get out of it? I'm going to sell it. Otherwise we can't really use it. And it's a bit difficult to convince them to just provide the data that they have, so that different people provide different type of data together. At the end, you end up with a situation where you can actually do more with the same stuff. And I think that there is quite a lot of potential to do something. So I would challenge the protection of everybody. Says, okay, data is gold, and data you need to leverage it, but sharing it also has a big impact and can actually provide more solutions and more ideas for everybody.
Mm-hmm. Okay, perfect to round up this episode of this podcast. Thank you very much, Michael and Martin, for this very inspiring discussion. Thank you.
Thank you.
Thank you.
Thank you for listening or watching this podcast. If this conversation inspired you, I invite you to subscribe and explore more episodes at datacenteruniversity.be, where we empower shared knowledge and spark new ideas for the digital leaders of tomorrow. Until next time, for more insights that drive digital leadership.